All right, so we're now moving on to a second part of this first video. I didn't create the first video because I found that one before in the past. I thought does a great job at explaining ratios and does it both visually and just the way that they explain. I thought that it was a great job, so that's why I wanted to have you guys watch that one. And then now this second video, we're going to discuss ratios and proportions now, and what we're going to be able to do. By the end of this video is now you're going to be able to tell if a table creates a ratio. So if I give you a list of numbers, you're going to have to determine are they a ratio or not. And by doing that, you're also going to be able to know if two ratios are proportional. So we're going to segue into that after that. And then the last thing is you're going to find out and learn what complex fractions are and how we can rewrite them. All right. So the last video that you guys watched was going about what are ratios and explaining that to you. And this one's now going to be able to have you go into it and say, well, can I determine if something's a ratio? And if they are, can I? If and I'm given two fractions or two ratios, can I determine if they're proportional? And then also, what is a complex fraction and how to solve that? All right, this video may be broken up into two separate ones, so meaning you might have three videos for this first section. We'll see how long this takes. All right, so one of the things you might have to be able to do is you might need to be able to determine if a set of information or a set of information that's given to you, if they all have the same ratio or not. And we're going to learn that when two ratios or when two sets of numbers have the same ratio, we can say that they're proportional, meaning that their ratios are equal to each other. So you might be given a table and you might have to identify. And one of the ways that you can do this every single time is you can take whatever relationship they're giving you, write it as a fraction, and simply simplify it. So when we're looking at cats and dogs here, maybe this is talking about different houses and how many cats and dogs they have. Well, we could take each of the cats and put it over our dogs. And then, whoops, that should be cats over dogs. And then we can just simplify our fractions and see, do they simplify to be the same fraction? And if they do, then that means that they have the same ratio. So I have this 1/2. It can't be simplified anymore. So here I have 2 over 4, and 2 over 4 can be simplified to 1/2. So that means, yes, this is the same ratio as that 1/2. I can look at this 4 over 8 and see, does this simplify to be 1/2? And it does as well. So that means it's also the same ratio. And I can look at 8 over 16 and see, does this simplify? And it does to 1/2. So that means all of these all simplify to give me the same ratio, 1/2. So that means that this table that we have is proportional, meaning that each of these houses, if we're looking at different houses that maybe have 2 cats and 4 dogs, we can say that they all have the same ratio. All right, so one of the ways we can do when we have a table is simply just put all of our fraction, all the points as a fraction and simplify and see, does it give us the same? The other thing that we can do as well is we can look and see, do they have, can we create or can we go from one number to the x using the same method? And what I mean by that is through multiplication. We can say, okay, well, we can do 1 times 2, and that gives me 2, and 2 times 4, or 2 times 2 gives me 4. So you see that we're multiplying those numbers by the same thing. If we look at the next one, well, 2 times 2 will give me 4, and 4 times 2 will give me 8. If we go to the next one, 4 times 2 gives me 8, and 8 times 2 will give me 16. So you see how we are multiplying each of our numbers by the same thing? That tells me that they're going to be proportional as well, because we're increasing both of them by the same rate. So in all these cases, we're multiplying them by 2, both the cats and the dogs. So that means that they're growing by the same rate, which guarantees that they're going to have the same ratio. So we could look at it one way and simplify our fractions. Or we can look and see, are we multiplying them by the same number to get to the next number? And if we are, that means that they are following that same ratio as well. All right. And this is going to be something that we're going to be using in just a moment when we're going to find out, are 2 points proportional? I'm showing you different methods that we can solve this and determine if things are proportional or not. The one thing, though, that you need to be aware of is if we look at this next table I have, all of these also simplify to 1/2. So they all do follow the same ratio. However, if you look here and say, okay, well, 1 times 2 gives me 2, and 2 times 2 gives me 4. So that means they're following the same ratio. You might not know, okay, well, 2 times what gives me 3? Maybe you don't know that off the top of your head. But what we can do then is we can also go back to that original number and say, well, 1 times 3 will give me 3, and 2 times 3 will give me 6. So it shows me that those two hold true. And then I can look and say, okay, well, I don't know 3 times what gives me 4, but I know 1 times 4 gives me 4. And I know 2 times 4 also gives me 8. So sometimes we might have to refer back to the original number just to make it easier for ourselves. What you cannot do is you cannot say, let me erase this for a second. You cannot use addition, right? You cannot say, well, 1 plus 1 and 2 plus 2, and then from here say, well, 2 plus what. You cannot use addition. Always try to look at multiplication, because sometimes when you do addition, sometimes it may seem like it works, but it won't. All right, so we want to make sure that we're using multiplication to find that same pattern. And sometimes it might be where we are multiplying each number every time, or we're multiplying from that beginning number every time. All right, but we want to see if that has a relationship. There's two ways you can tell. So when you're given a table and you want to know if they are proportional, if they all have the same ratio, you can either take each fraction and reduce it to see, well, what does it reduce to? Or you can go ahead and see, can I find a relationship that I'm multiplying the same number to each my cats and my dogs? All right, and it must be the same number. You're going to hear me say this all the time. Consistent. We must be consistent when we're dealing with ratios. All right, so now we're going to go ahead and talk about proportions and how we can determine if two ratios are proportions using different methods, and two of which I just showed you here. All right, so now we're going to move into being able to determine if two ratios are proportional, which is essentially what we did in that last problem with the table, but the difference is there we have multiple points. And we can use these methods as well, even on the table. All right, so I'm going to show you three different ways of doing this. So the first way, if ratios are proportional, it means that they're equal to each other. All right, so we're trying to see, are these two ratios in fact equal? All right, and the way that we can do that is we can take one method is by simplifying. And we can take both of our fractions and reduce them and simplify to its lowest form that we have. Well, 1 over 2 can't be reduced anymore, so it is 1 over 2. Then we can take that 3 over 6 and we can look to simplify and say, okay, is there any numbers that divide evenly into both 3 and 6? And yes, 3 does. And 3 divided by 3 is 1, and 6 divided by 3 is 2. So if they reduce to give us the same fraction, then that means that they are proportional. It means that they are equal to each other. So we can then make a statement that 1/2 is equal to 3 over 6. All right, so one way is simplifying. And some of you might be really good at simplifying fractions, and maybe this is the method that you choose to use. It is completely up to you, all right, of how you want to prove. To me, I think the third one we're going to go through is the best one, just because it's the most direct, and it's actually what we use when we solve proportions with variables. So it's something that we just naturally start using a lot of, but it's up to you if you're given this question, how you want to do it. All right, the other way is maybe you might look at 14 over 35, like, oh, I don't really know how that's I don't know how to reduce that. So maybe you're stuck. So what we can do then is we can look at these fractions as well, and we can try to determine, like we did on a table, can I figure out 2 times what gives me 14? Well, 2 times 7 does. So then when I can look at the bottom and say, oh, well, if 2 times 7 gives me 14 and they're going to give us the same ratio, then that means that 5 times 7 must give me that denominator as well. And since 2 times 7 does give me 14 and 5 times 7 does give me 35, I know that these are in fact proportional, and I can say 2 over 5 is equal to 14 over 35, right? So if we are multiplying both our numerator and denominator by the same number, then that shows that they are also proportional because they're growing at the same rate. All right. And if we wanted to, we could then say, well, 14 over 35 must reduce to 2 over 5. So the other way that we can do this is we can look at our numerators and denominators and see if we can develop a relationship that is the same for both, meaning that we're multiplying or dividing by the same number as we move from one fraction to the other. All right, so before we go into this third one, we're going to circle back to these two numbers just because they're easier to work with. All right, and one of the ways that we can do this as well is 1/2, is this equal to 3 over 6? Well, we already know it is. So when they are equal, there is something called that we can multiply our means and our extremes. You don't need to know that right now, but you will in the future. But what we can do is if you take the one numerator and multiply it by the other denominator, so 1 times 6 is equal to 6, and then you take the other numerator and multiply it by the other denominator, so 2 times 3, that also equals 6. If the ratios are proportional, that means that our cross products will be equal. So since these two were equal, we know that these two fractions are proportional. And that, so we can then say that they're proportional. We already knew that they were. So we can then go ahead and say, okay, well, these two fractions are equal. So when we look at this third problem, C, well, 2.25 and 3.75, maybe it's hard for you to reduce that. Maybe it's hard for you to figure out what you need to multiply to get to 9. So the other way that we can determine then is, are these in fact proportional or equal, is we can do the cross multiplication. So we take our one numerator and we multiply it by the other denominator. So 2.25 times 15. And this one, since we're determining if they're equal or not, I'm going to put the question mark above that because we don't know. So I should put the question mark there as well. And now we have 9 times 3.75. All right, I'm not going to go through of how to multiply. You can, if you need help with that still, you can go ahead and reach out and we can go through that together. But 2.25 times 15 is 33.75. And 9 times 3.75 is also 33.75. So since they're equal, we can say, yes, they are proportional, these two ratios. All right, so there's 3 different ways we can determine if ratios are proportional, meaning that they're equal. We can simplify both fractions to see, do they reduce to give me the same fraction. We can see if there's a relationship that we can multiply both the numerator and denominator that holds true and is consistent for both. Or we can simply cross multiply. Any one of these methods will work. Like I said, this is one that you'll probably be using more times than not. But even when we go to solve some of our proportions later on and word problems later on, you can use any of these methods to solve. All right, so now the last thing we're going to do in this video is just real quick go over what a complex fraction is and how we can go ahead and solve a complex fraction. Before we go into any examples of how to simplify complex fractions, let's first talk about what they are. And a complex fraction is a fraction that has at least one fraction within the numerator, the denominator, or both. So what we mean by that is we have fractions that we're normal to seeing of 1/2. A complex fraction might have that fraction 1/2 in the numerator and a number in a denominator like this. So you see here we have a fraction within a fraction. We have our overall fraction that we will look at here. And then within that fraction, our numerator has another fraction inside of it. It has that 1/2 inside. So we'll often say it's a fraction within a fraction. And it could be where it's only in the numerator. It could be where it's in the denominator. Or it can be where it's both, where you have a fraction both within the numerator and within the denominator. But the way that you'll think about this and the way you'll hear me say it going forward as a complex fraction is it's a fraction within a fraction. All right, so now let's go ahead and go through a couple examples. We're just going to go through one example of how we can simplify a complex fraction. All right, so this problem may look really difficult or really challenging. So, whoa, what is going on? You may not have seen anything like this before, but it's actually really not that bad. Before we go on and solve this, there's just one thing you need to know. What operation does a fraction bar mean? When we see these fraction bars and we want to think about it as an operation, right? Is that addition? Is that multiplication? Is it division? Is it subtraction? So what does it mean? And as long as if you know what that means, then you're able to do this really easily. So what you'll do is you're going to identify, okay, where is the main fraction? So when we look at this, say we say complex fractions are fractions within a fraction. So if I look, this fraction bar here would actually represent my main fraction, if I'm going to say that, my overall fraction. And within the numerator, here I have a fraction within my numerator and a fraction within my denominator. So what we can think about then, if we know what a fraction bar means, and that is division, then all this is telling us is 2/5 is being divided by 8/15. And then now we would just use our regular division of fractions that we know. Division with fractions, we keep change flip, so it becomes 2/5 times 15/8. And then we just reduce this and simplify. Well, we've learned before we can reduce beforehand. So before I go ahead and reduce, let me go ahead and remember we write them under one fraction. And then we look to see are there any common denominators or any common factors that we can reduce. So 2 goes into 2 once, 2 goes into 8 4 times, 5 goes into 5 once, and 5 goes into 15 3 times. So we multiply 1 times 3 gives me 3, and 1 times 4 gives me 4. So that means this fraction here of 2/5 over 8/15, written as a complex fraction, can be reduced or simplified to just simply 3/4. So we would have to reduce it. Remember, everything in math, we always have to simplify. So when we have these complex fractions, we need to simplify them. And all it means is it is a fraction within a fraction, and we're just going to ultimately have to use our division rules with fractions to rewrite to give us just one fraction that we are used to seeing. All right, that is it for this video.